Hey everybody, welcome back to my channel. This is Mr. Goldman with the Chapter 5 test solutions. Please, I will not restart. Woohoo! I celebrate my mistakes. Make sure to like and subscribe. Smash that bell button for notifications. And say hello to First Period. Woo! The excitement in this room. Oh my God. Oh man. Wow. All right. Here we go. Standard 1. Percent problems with a number line. For this first one, the most common mistake here, my favorite mistake, is people counted lines, not spaces. So make sure you are counting the spaces. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. And I know it goes from 0% to 100%. So I'm going to divide that line into 10 equal parts, and each part would be 10%. So that means that these 3 parts would be 30%, right? That means there's 7 parts here. That would be 70%. And now I have $12 covers 3 different sections, and they are all the same size. So I would divide 12 by 3, and I would get $4. So each of these sections is both $4 and 10%, right? And since there are 10 sections of 4, I know that the original cost is $40. Here, this represents 7 sections of 4, which is $28, right? We could have also just subtracted 12 from 40. There's a bunch of different ways to get this, but the key is find out how the value of each section and then calculate from there. The next one has 1, 2, 3, 4, 5 sections. So now I'm going to do 100 divided by 5 and get 20, and each section is 20%. So this represents 3 sections of 20%, so that's 60, and this is 40. And here, same idea, only I have 36 now. I'm going to divide 36 into 3 equal spaces. That is $12. So all of those 5 sections are $12. The 40% is 2 sections of 12, which is 24. And a few people did have a problem with this addition. 36 plus 24 is $60. So the original cost is $60. Down here, it's the same. It's also 5, right? And this first is 3 sections. So that means it's going to be 60% and 40% again. Same idea. But now we have to divide 3750 into 3 pieces. You were able to use a calculator, which made this easier. But it's 1250. Because 1250 times 3 is 3750, which means these are also 1250. 2 sections of 1250 is $25, and then you would add these 2 together, or multiply 1250 times 5. Make sure we're not wearing a hat in here, please. Thank you. And we would get 6250. I didn't take points off if you wrote 62.5. But since we're talking about money, write your answer like money, right? So that's standard 1. Standard 2, find the probability of a single event. This was a review standard. The probability of rolling an even number on a 6-sided number cube. Well, if I roll a number cube, I can get 1, 2, 3, 4, 5, or 6. The even numbers are 2, 4, and 6. There's 3 of them out of 6 total, or 1/2. What is the probability of drawing a face card from a standard deck of cards? There's jacks, queens, and kings in a standard deck of cards that have faces. So there's 4 jacks, 4 queens, 4 kings for 12 cards total, or 12 face cards. And there are 52 cards in the deck. That simplifies to 3 out of 13. And then we want to write that as a percent. So I go to my magical calculator, and I do 3 divided by 13. Is that, and I multiply it by 100 to give me percent, and I get about 23%. What is the probability of drawing a purple marble from a bag of 30 marbles, 6 of which are blue and 17 of which are purple? This confused some people. It's almost too easy. It says 17 are purple, and there are 30 marbles in the bag. So there you go, 17 over 30. As a decimal, we divide 17 by 30, and we get 0.56 repeating. And multiply that by 100, and we get 56.6 repeating percent, or however you wanted to round that. I was very lenient. Really, if you got the fractions, I gave you credit for the standard. This is next. I can find the probability of a non-uniform event. What is the probability of spinning purple? Oh, and a quick note. I did, when first, second, and third period got this test, there was an erroneous paragraph here that I crossed out. So this is the edited test. What is the probability of spinning purple? Well, there is one purple section out of, count them carefully, 1, 2, 3, 4, 5, 6, 7. What is the probability of not green? Well, you can do this two ways. How many are green? Only one. So the probability of getting green is 1/7. If I subtract that from 7/7, I get 6/7. And red, one of the most missed questions. A lot of people just put 1/7. There are 1, 2, 3 red sections. So 3/7. Standard 4. I can find probability of compound events in both / and problems. Mary's playing a game in which she rolls one die and spins a spinner. What is the probability she will get both the 3 and black? She needs to win the game. The probability of getting a 3 on a number cube or die is 1/6. The word and means multiply. The probability of getting black is 1/3, so we would have 1/18. Use the spinners at right to tell Paul what his chances are of getting the silver truck he wants. Well, truck is, okay, so silver is not 1/3, it is 1/4. So we have 1/4 times 1/3, and we got 1/12. This one is a little confusing. There are 100 students at South Lake Middle School. 25 enjoy swimming, 50 enjoy skateboarding, and 10 enjoy playing softball. What is the probability that a student enjoys all 3 sports? What does the word and mean? First period, multiply. So what's the probability that somebody enjoys swimming? Well, 25 out of 100 times. Probability they enjoy skateboarding is 50 out of 100. I'm going to multiply that by the number of people, or the probability that somebody enjoys playing softball, which is only 10 out of 100. Now I need to multiply all those things together. First, I'm going to simplify. 25 over 100 is just 1/4. 50 over 100 is 1/2. And 10 over 100 is 1/10. And I'm going to get 1/80th. There you go. So 1 out of every 80 students. So maybe one person at this school, if I were to make a guess, based on this information, that only one person at this school enjoys all 3 of those things. All right, make an organized list of all the outcomes of flipping 3 coins and find the probability of flipping heads all 3 times. All right, let's start with all heads. Heads, heads, heads. Then I can get heads, heads, tails. Heads, tails, heads, and tails, heads, heads. So my way to make this organized is I thought, how many different ways can I get heads twice? Right, I started there. And I kind of moved the tails this way. Now, let's do tails, tails, heads. Tails, heads, tails. Heads, tails, tails. And then tails, tails, tails. There are 8, right? And we should know this. You should, by now, be able to use the fundamental counting principle to verify that each coin has 2 outcomes. So we would multiply 2 times 2 times 2 to find the total number of outcomes for 3 coins, and we get 8. So heads, 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 that's only one of them. So 1/8. Make an organized list of all the outcomes of flipping a coin and rolling a 6-sided die. So we have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. There's 12. The probability of flipping tails and also rolling an odd number is 1, 2, 3. So 3 out of 12, or 1/4. Now we're going to roll a 9-sided die and flipping a coin. So we have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, heads 7, heads 8, heads 9, and then the same with tails. Tails 1, tails 2, tails 3, tails 4, tails 5, tails 6, tails 7, tails 8, tails 9. Now, the tricky part here was figuring out what is a prime number, because we want prime number and heads. 1 is not prime, 2 is, 3 is, 5 is, 7 is, 8 is not, like I did in the practice test. 9 is not, like some of us did. So there was 18 total outcomes. 4 of them are prime and heads. Moving right along, let's make some tables. You had to create a table. That's why I bolded it and italicized it. You had to actually make a table here. Getting heads on a fair coin and roll, so very similar. So we have heads, tails. As my event 1, there's 2 outcomes. My event 2 is rolling a 6-sided die. 1, 2, 3, 4, 5, 6. Heads 1, heads 2, heads 3, heads 4, 5, 6, tails 1, tails 2, tails 3, 4, 5, 6. Heads and even. 1, 2, 3. 3 out of 12. Or 1/4. Multiple of 3 on a spinners with 1 through 8 and tails on a fair coin. So we have heads, tails again, and now we're just going to go 1 through 8. 3, 4, 5, 6, 7, 8. This is going to look very similar to the one above. The key here is our number of total outcomes is changed. Instead of 12, we're now going to have 16 because there's 16 spaces in here. In the interest of time, I'm just going to fill in the multiples of 3 and tails. So tails, 3 is a multiple of 3, and 6 is a multiple of 3. Right? Because 3 times 1 is 3, and 3 times 2 is 6. So there are 2 multiples of 3 out of 16 total outcomes. And last one, the standard create a table to identify the probability of spinning red and shirt on the spinners below. So the first spinner is red, blue, green. The second spinner is, we'll do S for shirt, P for pants, and I don't know, we'll go show for shorts. Make our table. This is red shirt here. That's the one we want. Red pants, red shorts, blue shirt, blue pants, blue shorts, green shirts, green pants, green short. So there's 9 possible outcomes. Only one of them is red and shirts. So we have 1/9. Here we are, the tree. Create a probability tree to show all of the possible combinations of flipping a coin 3 times. The first time I flip the coin, there's 2 possible outcomes, heads and tails. The second time I flip the coin, well, if I got heads the first time, there's 2 outcomes. I can get heads or tails. If I flip tail on the first one, I can get heads or tails. So this is a tree for flipping 2 coins, or 1 coin twice. Now I'm going to add 1 more flip. So if I flip heads and heads, I can get heads or tails. If I flip heads, tails, I can get heads or tails. It doesn't matter. Every time I have the same 2 options, heads and tails. And now when we want to count total number of outcomes, we count here. We just count the ends. So there are 8 possible outcomes. How many different ways are there to get 2 heads and 1 tail? Well, for number 1, is that 2 heads and 1 tail? No, it's 3 heads. What about number 2? Yes. Right? Because it's tails, head, head. What about number 3? Yes. Heads, tails, heads is 2 heads and 1 tail. 4? No. 5? Yes. 6? No. 7? No. 8? No. So there are 3 out of 8. And all tails is just this last one. So there's only 1 out of 8. All right. Now Grace's outfit. She has the following options. Option 1 or event 1 is picking out a top, and there's 2 tops. So we're going to say she can go dino or flower. And then for bottoms, so for each of these, whatever she decided, dinosaur or flower, she can still pick all 3 bottoms. So overall tutu leggings, overall tutu leggings. So without the shoes, she now has 6 options. But for each of these 6 options, she has 2 options for shoes. Crocs or gold slippers. Crocs or gold slippers. So now there's 12 possible outcomes. 2, 3, 4, 5, 6, 7, 8. How many possible combinations are there? 12. Now, this was the most challenging question. What is the probability of Grace wearing a dinosaur shirt or her gold slippers? Okay. I'm currently wearing my, blue hoodie, but I'm not wearing my brown shoes. But if somebody asked me, are you wearing your blue hoodie or your brown shoes? I would say yes. Because or is either one. So if she is wearing one of those items, that is a desired outcome. So all of these, let's get it. These first 6, because she's wearing the dinosaur shirt, and all of these, those are all good. Those are all 6 of those, she's wearing dinosaur shirt or gold shoes. But we also have to add any time she's wearing gold shoes with her flower shirt. So there are 9 total outcomes. So this question made you use the probability tree that you made. A lot of you made perfect probability trees, but you weren't sure how to use it for this question. So make sure we are using, I want you to show me that you understand how a probability tree works. So that was the test. There we go. Guys, if you're watching at home right now, I wish you could feel the energy in this room with first period. Huh?